Dhruvang and Priyanka, Dhruvang Hingmire and Priyanka Gunjikar stay in Pune, young architects, also graduates of the Ecological Society, as am I. So I met them last year, and in brief interactions, able to see how sincere they are in the vision that they have chosen to pursue. They're architects of building in mud, and their focus is to create cement-free, eco-friendly homes that stay cool using natural materials and lime plaster. It's a very brief introduction for two young people who are actually very passionate about the work they do. But so with this, I will hand it over to you, Dhruvang, and why don't you walk us through all the tests that you did? I'm sure a lot of discussion will be generated from that.
Sure. I'll just share my screen here.
Yes, please go ahead.
Yeah. Is it visible?
Yes, yes. Go ahead.
Sure. So thank you, Manisha, for not just involving us from the get-go in Punaravartan, but also I think following up with us so tirelessly, because I think it wouldn't be possible to even reach this halfway stage right now where we are if that that timely nudge wasn't given from your side. So thanks a lot for that as well. And I would just like to continue from what even Yogananda sir also said from the earlier presentation, that even after the we'll run you through what we did and our findings briefly after this. But after the exercise, we are also of a similar opinion that construction blocks, whether to be made with recycled clay, if and only if the clay doesn't have any other application and needs to be used urgently, is the most efficient way to use it. Otherwise, we might discuss in detail about what are other alternative applications as well. So I'll just rush through some of the applications where we were coming from. So these are just some brief images. This is a structure we did in brick and lime mortar. So here the mortar is lime and brick powder. So brick powder is from a local kiln which has been ground and used in the mortar. We also work a lot with Adobe, as what was also presented earlier. This is unstabilized Adobe in another place near Pune. So these are the kind of applications we started off when we are looking at Shaadu clay particularly for. Or even to use as mortars in structures like these, for example, stone and brick. So the mortar that goes between the bricks and the stone could be with some amount of clay along with some additives as per the design of the mix, so to speak. Not just Adobe. So to the left is Adobe. To the right top part, you can see CACB, again compressed stabilized earth blocks. Similar application is possible with these Shaadu blocks that we can make, and cob as well. So right bottom corner is an image of one of our ongoing cob structures. So that is also a potential application, especially because cob is known to be a technique which is good with clay-rich soils, essentially. So you may have to add lesser amount of aggregates like sand or sand-like material when you're working with cob and fiber or something like that. So that was the initial idea when we started off doing some experiments with the clay samples that we received. Before going ahead, I'd like to specify that we received two kind of clay for the sample. One was near to pure clay, which was done as per the initial video that Manisha shared at the onset, where it has been diligently, separated from the other material and packed well, and then I think sent to Punaravartan. So that is the clay we have currently used for all the testing, so that we can compare directly. Because as mentioned earlier, with the other clay where there is some amount of impurities and other matter that may not be able to we won't be able to easily quantify. We might have to do recurring tests. So we have not used that clay as of now. We have just used the first sample, which is the pure clay. So this is the process that we followed, which we crushed it, we sieved it through 1.18 sieve, and then this fine clay was ready to be mixed, dry mixed first, and then wet mixed to make the blocks that we eventually did. So we did sort them first, if like some amount of paint and other matter we did set aside, sieved it, dry mixed it, then made blocks from it. The blocks that we made were small blocks, around 4 by 4 by 4 inches. They were cured, and after the curing process, we did a number of like some dry compressive testing and some wet compressive testing as well on these blocks. So I'll just run you through the kind of blocks that we made. First, I'll run you through the materials that we used in this. So one was the base material, which is the fine clay or shadow that we got. We also used clay soil that we had from another site to be added with this shadow for some of the blocks. Here specifically, we didn't have access to a good quality murum soil essentially, or a soil that is essentially sandy. The reason of choosing clay soil is because in the region around Pune, we'll see this kind of soil more. But we will discuss more in detail as we go forward about the possibility of using murum as well in place of side soil. We did use lime, which was slaked, and then the slaked lime was added to the blocks. Brick dust was a major material that we did use. I'm not calling this surki because, as I've also learned from Yogananda sir and Pramod sir and Sudhakar sir, we have been collaborating with them for multiple projects and have learned a lot from them also. I learned the difference between surki, which is essentially under 90 microns. If the brick dust is sieved, it is called surki, which is 100% pozzolanic material. But here, because on site or when we are actually working, it's next to impossible to sieve brick dust under 90 microns on site. So we are using brick dust, which is essentially a combination of, you could say, surki, which is some particles under 90 micron, and the remaining particles could be considered as aggregate for the soil as well. Then we did use some crushed sand and some cement for the stabilized mixes also. So going ahead, this is how we structured what we are going to test. So we broadly we classified the first set of testing we did was to just understand a baseline of how the shadow clay is and how it is behaving. So those we named as blocks A, which is essentially clay, then one block with clay and fiber and one block with clay and sand, to see how it responds when it dries or when maybe it is tested. Then we did add some blocks. B was essentially stabilized shadow blocks. So similar to what Yogananda sir did present earlier. Then we also did experiment using shadow along with lime and brick dust. So lime and brick dust is something that we regularly use in many of our structures. So we did want to understand what the addition of shadow does to a mix like, you could say a tried and tested mix like lime and brick dust, which have been used through generations now. Then the next lot of testing we did was soil stabilized with cement, but using the shadow as an additive, not a major portion of the soil, but just as an additive. And then a mixture of all these, as using a mixture of sand and brick dust along with lime and shadow. So this is what we did. And to the right is the list, that's something that we would like to try soon. So like what I mentioned is murum essentially is something that has a lot of sand. It is essentially soil that is not directly used for applications like agriculture or forestry. So it is a material that naturally goes well with a material like shadow. So we would like to explore that further through various of these blocks. And secondly, we would also like to explore clay slip blocks, essentially, where clay slip is something where you just add, clay to water to make to water to make a paste first, and then dip straw in it to make clay slip that is used for multiple applications. It can be used for lightweight blocks for construction as well, or blocks that give you a lot of thermal insulation. And it also can be used for plastering or making murals and many artistic applications as well. So I'll just go to the first lot of blocks. This was the first block that we made. We call it A1. So it was essentially just the Shaadu. The way we received it, we processed it and made blocks from it. One important thing that we did analyze was we did expect the block to crack a lot, but it did not crack at all, even though it was pure clay. But there was significant shrinkage after the block dried. So you could say around 35% of shrinkage by volume was seen. Um, it was not brittle also. Very surprisingly, it was not brittle at all. It was extremely strong, and I think that makes it a good material to be used in idol making in the first place. So applications like plastering, for example, or making tiles from these unstabilized tiles, or maybe through experiments like Shashank's experiment that we saw in the beginning, we might explore that aspect also. But essentially, we got to know the nature of this clay through this block. We did not test it for any loading. This was just to understand the property. And then to reduce the amount of shrinkage, we did try adding some fiber. So the fiber used here was bagasse that came from sugarcane, essentially, that was cut into small pieces and used to make a block. So we did see around 5% reduction in shrinkage after adding fiber. And after adding sand to it, equal amounts of Shaadu and sand, there was considerable reduction in shrinkage, so around 10% reduction in shrinkage after adding sand. So we do want to explore in the future the possibility of adding fiber as well as sand. So we will be trying more blocks where we do add sand and fiber to this soil, and those blocks could be explored to be used as unstabilized adobe or unstabilized cob or any such technique. And I think that is along with finishing techniques like plaster, the I think the major use that we are seeing for the blocks as of now. Do you want to add something? Moving on to, so I won't go into a lot of detail with this, because I think this is just the process of what the detailed study that Yogananda sir also presented in his presentation. So we are not there yet. We are just in maybe 20 to 30% of what they have managed to achieve in such a short time. So this was just an experiment to see how the Shaadu works with stabilized essentially sand and cement. So a stabilized Shaadu block, you could say. So we did wet compressive strengths on these with different proportions. There was also different sieving that we also tried with some of these blocks, because we also thought that fine sieving like 1.18 mm on site may be a little difficult to achieve. Especially for these two blocks, we did sieve it through a larger sieve, which was around 2 mm sieve for these. But we did see that it was also dusting a little bit after drying. But there was considerably decrease in the shrinkage percentage after stabilizing these blocks. Um, Moving on to using site soil along with Shaadu. So some of the sites that we are working on, if we add Shaadu as as an additive to the block, along with a stabilized mix, essentially. So we did see that in some of these mixes. So these two mixes, especially the compressive strength wasn't great that we achieved. So then we worked on it further, and sorry.
This is the problem over here. Basically, is what we had was clayey soil, but this is something we really want to explore, because we would like to give this a try with sandy soil, where clay, the binder is generally very, very less, and you would want to add something like Shaadu, which is giving that effect. So I think that is one of the things that we would want to go ahead with if we want to use these blocks.
And then coming to lime stabilized, not stabilized essentially, but lime mortar blocks, you could say, where we added some Shaadu and experimented. So you could see that the top, proportion where essentially there is more aggregate, because this is pure clay, would work better with a dry compressive strength. So the strength we achieved here was 3.27, and I'm sure we can better that also with a better, better mixing and a better proportion after this as the next stage. So I am, especially with all these blocks, we are more optimistic about using these along with, say, lime and brick dust to get a good dry compressive strength, and eventually also to get a good wet compressive strength, because we would like to explore this as well in the future of wet compressive strength of lime blocks. So we would be experimenting with this also.
So in this, one thing that Dhruvang earlier mentioned, the brick dust percentage is quite higher as compared to some, like generally in proportions we take 1:3 if we are using mortar or
Lime mortar.
any lime mortar essentially. So here we increase the percentage of dust, assuming some part of the brick dust will act as surki and will be part of under 90 microns to stabilize with the lime. So that was the idea when we tried these blocks.
But this is more of guesswork and testing from our side. We have not at all followed any, a scientific way of arriving at these proportion. It is just usually on site whenever we do any kind of sampling and testing, we try the testing with varied different mixes to see how the blocks are functioning. Say, for example, with a greater mud to sand ratio versus a greater sand to mud ratio. So we did the same before arriving at these proportions, and then selected a few blocks from them to be tested later. So these are, an intermediate stage that you are seeing. There was a stage before this, and there will be a multiple stages after this exercise as well. Yeah. So yeah, sorry. So we also did try one with just lime, sand, and shadow. So again, a good compressive strength, wet compressive strength of 2.14 approximately. We would like to better it by adding more sand to it, definitely. The shrinkage was also under control, but can be controlled further. And mainly this was the only mix where wet compressive strength was greater than 2 without adding cement, essentially. So this is something that could be also looked at later when we test for further blocks. Yeah. Anything you would like to add? Yeah. So I think this is the testing that we did till now. Like I said, we would like to explore with more sandy soils and say murum as a material to be used along with this, and explore more with the initial lot of blocks, which was essentially the A blocks, where we're using shadow and just shadow and sand and shadow and fiber to have. We are excited to do some plasters with these, especially because I think, especially interior plasters or plasters which are not exposed to moisture or direct water or rain, will have a good application in construction field. But especially when we are working with clay and we are depending a lot on stabilizing the clay. I think, and I second Yoganand sir when he says that it is better to be avoided, if because we'll be using a many more, a lot of quantity of material to stabilize the shadow in the first place, and then we'll be, like we discussed earlier, we will be arriving at a product which is not essentially recyclable. I think that is the question where we started the entire exercise from. That if you are arriving at a product which is not essentially recyclable, then I don't think it is worth the amount of material and energy that we put into making the block or making a stabilized mix, rather than looking at applications where one doesn't need to stabilize and gets good strength, or gets applications where strength is not essentially the prime criteria for testing.
I think I'm leaving cement or lime aside, any kind of stabilization aside. The one thing that we have to add to this soil, if we want to use it as a building construction material, is going to be sand, which is the costliest material. I mean, with the sheer proportion that we'll need for the sand, I think that's what is not going to make this as economical, or it will only be restricted to only certain people being able to use it, which might be a problem.
Or ecological
Or
as
ecological,
well,
of course.
with quarry dust or sand being used almost everywhere illegally. So but we did discuss in brief that applications like cob, for example, could be with high clay soil we have seen work well when we are using unstabilized mud to make clay to make cob houses essentially. So this could be used with a high fiber content to make cob. That is a potential application. But again, the entire point of building with earth or mud in the first place is to use local materials to make the house. And if the house is not being made in the place where the shadow is available in the first place, it again might defeat the purpose of transporting the entire lot to a site which is somewhere far away and then using it for construction. So there are some reservations in terms of application, in terms of ecological as well as economical, feasibility of using this for construction. Thank you.
Wonderful, Dhruvang and Priyanka. Is that the last slide?
Yes.
So I have a number of questions, also knowing that there are certain people in our audience who are not architects as such. I think between when I hear you speak, there are certain assumptions that you all are taking for granted but in my mind, there are questions. For example, Hans brought up this question of the fact that if we add too much cement, it becomes, we're taking it out of the recycling circle. So a very basic question, this time as a non-technical person. When you build with mud, right, Yogananda ji, isn't there an optimum amount of time that you want that structure to stay in place without disintegrate?
See, it is something like this. You have plain mud, unstabilized buildings all over the world. If they are really happy with unstabilized mud, why should we look for a different solution?
Correct.
See, the question comes to the people who are living in such buildings and what kind of lifestyle they have. Are they mentally prepared to maintain the buildings? Are they worried about erosion due to rain? Are they mentally prepared? So we have changed our lifestyle. So the question is, what is the expectation?
Correct.
So that is, I think, depending on the expectation, solutions can emerge and we cannot generalize any solution.
So we are not saying that there is a general optimal duration for which a building must stand.
No, it is something like this. I would generally comment casually till you demolish.
Till you demolish.
Because maintenance is something which has to be accepted when you propose to construct. Construction of a building and maintenance go hand in hand. So if you are living in that building, I have seen 200, 300-year-old houses. Very nice, very well maintained. There is no problem. And especially masonry works very well when you don't have steel. Reinforced concrete is the problem. Because if you don't maintain such buildings, it is much worse there. Okay, so as far as the buildings are concerned, if you maintain, I think it is high time maintenance as a subject should be introduced to both civil engineers and architects. Because half the problem is in maintenance. It's not in the material, whatever has been used.
But in terms of an ideal way to use a material, are you saying that if you can keep the material in a form that even after demolition, it can be used again and again, that's the ideal scenario?
Well, I would put it this way. See, you're going to have building construction activity continuing. It's not going to stop. So, all the buildings which are getting demolished is the resource for the next building. That is why I say there is nothing like one has to be worried about, oh, are we going to get the clay back if it is mixed with lime and cement? None of these questions are important because anyway, they are going to continue building. If we can switch over to reusing, recycling, building demolished waste, because we can have quarries, crushers, wherein, it is already there in Bangalore, it is there in Hyderabad, wherein we can process the material and then recycle it back as fine and coarse aggregate so that you don't have to depend on the natural sand or manufactured sand.
One of the things that Sudhakar ji was mentioning on the phone calls that I had with him was the idea of instead of using, say, lime or cement or sand, would it be a possibility or something we can experiment and explore of using industrial waste? So, which are those industrial wastes that could be combined with clay to give us maybe a new material? What are your thoughts on what are your
That's exactly what I had put it in one of the slides. All the industries, okay, whatever we have, we should look at the waste what they are generating and utilize that and not depend on the natural materials. So that is how we have been able to give solutions to TVS Foundry. They have recycled their own waste. So aluminum industries, like a bauxite mine, there you have red mud as a waste, fly ash, pond ash, several such ways, granite fines, all the granite polishing and cutting industries have fines. So we need to survey and look at the kind of industries, whatever we have, and look at the byproducts. I would rather call them as byproducts of these industries, and they are resources for us. Only then there is some ecological sense
in doing this. Correct. The other point that Dhruvang and Priyanka brought up also was this the challenge of using something locally. So you're not creating another carbon footprint by transporting it all. I mean, luckily, all the architects that we have sent the material to was within a radius of Pune city only, because eventually every city will have to find architects around them that would be able to absorb this material, right? So what I learned also from your conversations is that there cannot be a one-size-fits-all kind of formula, even though now Mrinmay team has come up with a particular combination that can be used.
That is only a guideline.
Only a guideline.
It's only a guideline. If you don't want cement, we can use lime pozzolana. No cement at all. You can produce excellent quality stabilized adobe brick with lime and pozzolana. Pozzolana, there are a lot of examples of pozzolana. Rice's ash is one such pozzolana. GGBS, which comes from steel industry, okay, ground granulated blast furnace slag, that can also be used. Surki, when it ground to a fine material, that can be used as pozzolana. So we don't have to depend on cement. You can produce your own cement. Correct. That is where I look at trying to understand the process involved in the production, and you can produce your own binder. Locally, you can produce. So local employment generation can happen. That is where I am coming to. In fact, livelihood of people is something which we need to be more concerned with. Yes. Wherein most of the lime kilns, if you look at, they're all small scale lime kilns. They're all, kind of poor people. So we can give them livelihood, use lime with a combination of pozzolanic material, and you produce your own cement, whether it is to stabilized mud block or to look at mortars for construction, which can also meet the standards. There is no structural compromise. You can meet all the standards without using Portland cement. So you decentralize the whole thing. There is enough knowledge about all these things. One has to make up their mind and try to do it.
I think it's very exciting to think if we can do a small scale kind of industry which is decentralized and employment, rather than again expecting some big builder to step in and say, okay, we are creating this huge infrastructure to recycle all of this.
The other thing I feel is, let's not intellectualize it too much, because what we need today is employment. People need employment. You generate more employment locally. You respect the artisans. They are not laborers. They have some wisdom. They have some skills. Respect that. And with them, we can work with our understanding, and they will do a wonderful job of it. Wherein we can recycle most of these materials with the kind of knowledge what we have and generate more employment and decentralize. This kind of migration to cities, I think it is killing.
That's so incredible. We have one last person waiting to present, sir. Dhruvang, Priyanka, you want to say anything, or can we hand it over to Vaibhavi now?
No, let's proceed. Yeah.
Yes. Okay.
Only one question I have for Dhruvang, just out of interest, the mixed proportion, when you mention, it is good to mention whether it is by volume or weight. So
Yeah.
communicate it, that's all. It is more for communication. Because in science, we need to improve our understanding that communication is something which is necessary. And number of specimens you test, it is good to keep a track of how many number of specimens, because the statistical variations do happen, so that we try to go back and cross check whatever results we are getting. And number of days of immersion before you give it for testing, that is also something which is good to keep in mind. So all these things, in a way, to continue it forward. All the best to you both.
Thank you so much, sir.